today we are going to finish solving those quadratic equations from yesterday using the quadratic formula. So yesterday we found using the discriminant and we found out the number and the nature of solutions. Today we're going to go fully into the quadratic formula. And again, remember that we are using the A, B, and C based upon it being put equal to 0. The A being in front of your square term, your B being in front of your variable, and your C being your constant, taking the sign with you. And so we have been practicing our song, and so remember it's x equals negative b plus or minus the square root b squared over minus 4ac all over 2a. And that's just a way to help memorize this formula. This formula, if you're going to use it on your ACT and SAT. It is a formula that's used in college algebra. It's not one that's going to be going away. And the way I always remember it is, instead of negative b, I always think of this as opposite b. So if I'm plugging in a negative, it's going to be positive. If I'm plugging in a positive, it'll become negative. Let's go ahead and go to the problems and work a couple. So again, like I said, we are just picking up with where we stopped yesterday and going further. And so we stopped after we found the discriminant. And this number is going to come into play today as we go through the formula. So I always start with writing down the formula. And it says x equals negative b, but it's whatever variable you have. And in this case, our variable is n. So n equals, I usually do this over 2 lines. That way I have room to work everything. And so opposite b plus or minus the square root of b squared minus 4ac all over 2a. Well, we've already found the b squared minus 4ac, so we've already know what this number is. We don't have to find that again. So we're going to replace that with the 0. And so when we plug in, n equals opposite b, so that's going to make it a 12, plus or minus the square root of 0, all divided by 2 times a, and the square root of 0 is nothing. So that goes away. In this problem, we're left with 12 divided by 2, or n is equal to 6. So our one solution is 6. We will come back to do the imaginary solutions at another point. For now, we'll go on to question 3 and work that. Let's go to the last problem. In this one, we had 2 real solutions. So when you have 2 real solutions, you could end up with 2 integer values, you could end up with 2 rational values, and you could end up with something like we had like in the last problem where there's square roots. So let's figure out what we have here. So first off, we're going to go ahead and plug it into the formula. So x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And so on this case, the opposite b is going to be a negative 3 plus or minus the square root of 1089 all divided by 2 times 2. So this is a big square root. First thing I would do is check to see what is the square root of 1089. If I don't have anywhere else to start, that's where I always start. And in this case, it came out to be 33. Or you could have done the division trick that we were just doing, and I would start with dividing by 3s. And then saw that I had 121 left, and then I would have gone with 11s. So now, I know what that is, so I can come back over here, and I'm going to go ahead and plug in my numbers. And so negative 3 plus or minus 33 divided by 4. And just like when we had the taking the roots problems, at this step, when there's no longer a square root, you have to split it into its two parts. You have to find out what those two fractions are going to be. So negative 3 plus 33 divided by 4. What is that going to be? So that's going to be 30 divided by 4, which reduces to 15 halves. The other one is going to be a negative 3 minus 33 divided by 4. And so when I simplify that down, I get a negative 36 divided by 4, which is negative 9. So my solutions on this one are positive 15 halves or a negative 9. Try the problem on your own for the next one.